Hello, algebra students. Mr. Lawrence here, and we're going to be writing some functions today. Remember, the function is going to be what changes our input into our output, and we'll get a more formal definition later, but let's get comfortable with them. Now, I mentioned in class on Friday that it was too easy to just tell me the next three numbers. I want to be able to figure out the 50th number, or the 500th number, or the 600th number. So some of you saw this sequence in class today, and so I'm going to put it into this table that I've made. Now, by the way, these numbers are what's coming out of the function, so therefore these are my outputs. And remember, my output is designated as f of x, right? X is the input, and it goes into the function. So that's the input, x is the input, f of x is the output. So I'm going to put x here, and I'm going to put f of x here. All right, so I'm going to fill in these numbers, the 5 and the 9 and the 13. So 5, 9, 13, 17, 21. And since this is the first output, this is the first input, right? The second output, the third output, the fourth output, and the fifth output. Now we're going to go all the way up to the nth output. N is just some unknown number. All right? Now, this is really easy. First of all, to go finding the input, the first thing we want to do is find our first differences. And most of you know this already, you just don't know to call it the first differences. That is, most of you told me, hey, Mr. Lawrence, it's going up by 4. You're absolutely right. The first difference is 4 every single time. Okay, plus 4. Now, when things are going up by 4 every time, think about it, 4, 8, 12, 16, those are going up by 4. What are those? Those are multiples of 4, aren't they? We're going to take this 4 and we're going to multiply it by n. Yeah, let me get a different color here. We're going to go 4 times n. I'm guessing that this 5, 9, 13, 17, 21 sequence of numbers is similar to this one. And that's why I'm calling it 4 times n. Now I'm going to do this comparison line. I'm going to put little spaces, 1, 2, 3, 4, 5. I'm going to put 1 in for n. 4 times 1 is 4. Here, let me even show that. I'll put 1 into my function. And so I'll have 4 times 1, which is 4. Okay? And then I'm going to put 2 in, and I'm going to get 8. I'm going to put 3 in and get 12. 4, I'm going to get 16. 5, I'm going to get 20. Now, that's just this sequence here, right? There's a small problem. Do you notice it doesn't match? Yeah, it doesn't match. 4 is 1 less than 5, so I have to add 1 to 4 to get it to 5, don't I? 8 is 1 less than 9, so I have to add 1. 12 is 1 less than 13. I'm going to add 1 to 16 to get 17. They're all 1 less. So my nth term isn't going to be 4n. It's going to be 1 more than 4n, or in other words, 4n plus 1. There's the nth term. Now my function will become f of x. That'll equal 4x, because I'm putting x in, not n at this time, plus 1. And now if I want to figure out the 800th term, I'm going to put 800 into my function. So I'm going to go f of 800. See my 800? And that's inside the function, right? It's my input. And I'm going to put 800 here. All right, so 4 times 800 is 3,200 plus 1, which is 3,201. I don't know about you, but I'd much rather do it this way than try to list the first 799 members and then figure out what the 800th one is. I'd rather do it this way. All right, let's try another one here. And by the way, what type of function is this? This is a linear function. See the equation? The highest exponent here is 1, right? This is a linear function. Linear. Right, very important. Okay, so here I have a new sequence of numbers. I'm going to copy them into my table. My x my input. I'm going to use g of x this time just so you don't get spoiled by always seeing f of x. Use g of x, h of x, k of x. They all just mean a function. And these are my outputs. These are my g of x's. So I'm going to put 9, 16, 23, 30, 37. And then this is my first input, first output, second output, third output, fourth output, fifth output, and I'm after the nth output. All right. Remember, step one, after I've made my table, is find the first differences. Some of you already see it. Plus 7. That's plus 7. That's plus 7. And that's plus 7. So my first differences are all going up by 7. That's kind of like counting by 7s. 7, 14, 21, 28, 35, etc. Okay, so my function, or my nth term, I'm guessing it's going to be something like that, because those all go up plus 7. So I'm going to take that 7, I'm going to multiply it by n. I'll do my comparison line, and notice I write them right under the other numbers, so it's really easy to figure out. I take 1 and I put it in for n, so 7 times 1 is 7, 7 times 2 is 14, 21, 28, and 35. Now I compare. How do I turn 7 into 9? Well, I add 2. How do I turn 14 into 16? I add 2, add 2, add 2. They're all 2 shy of the black ones, all the purple ones. So I must take 7n and add 2. And there is the nth term. So now I know my function. My function is g of x, and that'll equal 7x plus 2. And again, it's a linear function, isn't it? It is linear, right? Because the highest exponent is 1. Now let's find, I don't know, the 40th this time. Let's find g of 40. So I put 40 in, and I get 7 times 40 plus 2. And so that's going to equal 280 plus 2. G of 40 is going to equal 282. That's pretty easy stuff. All right, here's another one. I'm going to throw a small curveball at you. Not a big deal. Start it the same way. I tell you what, let's call this one h of x. H of x. H is my function this time. There's x. This is going to be first, second, third, fourth, fifth. And then I want the nth term. Okay. First output is 5. My second output is 2, negative 1, negative 4, negative 7. All right, step 1, go find the first differences. Always find the first differences. So it looks like I'm subtracting 3. Then I'm subtracting 3. I'm subtracting 3. And I'm subtracting 3. All right. So that's like going in the negative way. Like if I went 3, 6, 9, those are adding 3 every time. So this must be negative 3, negative 6, negative 9, negative 12, etc. So I'm going to take this negative 3 and I'm going to multiply it by n. So I'm going to do negative 3n. Do my comparison line. And I'm going to get 3 times 1. Negative 3 times 1 is negative 3. Then negative 6, negative 9, negative 12, negative 15. And I will do some comparing. How do I turn negative 3 into positive 5? Negative 3 plus blank equals positive 5. Well, I think it's plus 8, isn't it? I can make that x, and I could add 8 or add 3 to both sides. Yeah, and I'm going to get 8, so plus 8. How do I turn negative 6? Oops, sorry. How do I turn negative 6 into positive 2? Well, I add 8. How do I turn negative 9 into negative 1? I add 8. It looks like I'm adding 8 every single time. So I'm going to take negative 3n, but I'm going to add 8 to it. That causes my function to be h of x, h of x, and that's going to equal negative 3x plus 8. All right, So I don't know which one you want to find this time. How about the thousandth term? Let's go h of 1,000, and that'll equal -3 times 1,000 plus 8. All right, so it'll be -3,000 plus 8 should be -2,992. And there you go. Man, this stuff is easy. And you're going to feel so smart when you do it. And there's going to be college kids that have a hard time doing this. This is a Mr. Laurence special with some help from Mrs. Young and Mrs. Clark. You'll see where Mrs. Clark comes in later on. But this is something I created a long time ago when I was learning to be a teacher. And Mrs. Young helped me while we were here. We shared some ideas. And some other teachers, Mrs. Sopko, Ms. Warnoff have helped with it. And it's so simple to do. All right, let's do one more. All right, so let's see. Let's call this one f of x. So we're going to do f of x, and this is going to be x, and we're going to have 1, 2, 3, 4, 5, and of course we're looking for the nth term, and then we're going to fill in 1.5, 2, 2.5, 3, and 3.5. Step 1 is still to go find those first differences. So it looks like I'm adding a half. I'm adding a half. I'm adding a half, right? To move from 2.5 to 3, 2 to 2.5, it looks like I'm adding a half every single time. Well, that means I'm going to take the 1/2 and I'm going to multiply it by n. So it's going to be 1/2 times n. I'll do my comparison line. I'm going to multiply 1 times a half. Well, that's a hard one. Better grab your calculator. 2 times a half, that'll be 1. 3 times a half would be 1.5. Or 3 halves. I would get 3 over 2, but that's a mixed number is 1.5, right? 4 times a half, 2. 5 times a half, 2.5. What do you notice about this black numbers? They're all 1 short of the red numbers. I have to add 1 every single time, right? Okay, so that means that the nth term will be 1/2 of n plus 1 whole. My function, therefore, is f of x equals 1/2 x plus 1. Let's find f of 200. So I'm going to do f of 200, and I will get 1/2 of 200 plus 1. Well, half of 200 is 100, plus 1 is 101. There you go. All right, by the way, what kind of function is this? What kind of function is it? It's linear. Yeah, it's a linear function. There you go. All right, that's it for the video. No video quiz tonight. Mr. Laurence signing off. Have a good night, everybody.